I guess it's 5 o'clock, so I guess we'll start it off. If you're here for the OT, security interest group, you're in the right place. If you're not, well, might as well stick around. Should be interesting. But this is going to be our presentation about the intro to OT security. So yeah. If you haven't already, join the Discord channel. They sent an announcement about this, how to join the different interest groups. But if you don't know, there's a role drawn channel. Just go into that, select whatever interest groups you want to be a part of. I recommend checking them all out. They're all pretty cool. But since you're here, might as well join the OT security interest group. Additionally, we just sent out sign-in for if you're here. So that's in the sign-in channel. Give it a second to do that. Yeah.
So I'm Lucas Brown. I am a junior cybersecurity major. I did 2 security co-ops at Stroud Technologies. I'm from the Northern Virginia area. I played ice hockey up until my senior year of high school, and then randomly switched to badminton, where I'm the vice president of the badminton club. I like travel. Can see photos of Iceland, Ireland, France, Luxembourg, and I think Belgium. And that's also in the top right corner. You can see my cat. His name's Snap. So, yeah.
My name is Lucas May, so also another Lucas. I'm also a third-year CSEC major. I'm from Western Montana. I enjoy backpacking, physics, and astrophotography. All those photos are photos that I have taken, and that's my cat named Dolce. All right, now, Alex.
Hi, I'm Alex. Hi. Third year cybersecurity major. I'm currently doing a co-op for Nespresso in Barcelona, so pretty late for me. And I'm from Geneva, and then what am I doing? I'm at the RIT soccer club, and then I like skiing too, so, and then these are photos I've taken. That's a crazy sunburn I had this summer. Yeah, that's about it.
All right. So that's who we are, the industry group leads. What we're planning on doing over this meeting is we're going to cover what is OT. If you came and talked to us at the Jenna Ritzek meeting, we probably told you what it is, but just going to recap it real quick. Then we're going to talk about why we even should secure OT. And then we're going to do a quick overview of some OT cyber attacks. They're not going to be too in-depth, and some of them we plan on going into a full meeting into later in the semester. Then we're going to go into some of the specific challenges with OT security, and then kind of what even is our plan for the semester. So yeah.
So what do you even need to know to do OT cybersecurity? Well, there's a whole lot. There's a lot of moving parts at play. But for what you actually need to know to be a part of this interest group is absolutely nothing. We started from absolutely nothing last year, so we kind of know where the start point is, and it's just what is even OT? But yeah, that's kind of the main focus. So what even is operational technology? Well, it's the hardware and software systems that control industrial processes. So think the control systems that make a water treatment plant work, or the different kinds of things that are connected to an electric grid, or different manufacturing facilities, really anything in the critical infrastructure sectors. So, and also there's this term you probably will hear if you go to more meetings, is industrial control systems. That is a subset of operational technology. So think of OT as kind of the more broader term, where it incorporates everything, including firewalls, whereas industrial control systems are specifically for the control aspect. So that doesn't include things like the industrial protocols and whatnot.
Yeah, for this interest group, ICS, or industrial control systems, and OT are going to be somewhat synonymous, because we're going to be focusing more on those industrial processes. But just keep that in mind, that actually in industry, those are two sort of separate things. Another kind of term we got to cover here is this OT-IT convergence. I mean, it's pretty simple what it is, but it's an increasing IT-OT connectivity. You got these IT, kind of what you're familiar with in your enterprise networks, and they're kind of increasing the connections into the OT space. Additionally, in a lot of these factories, or whatever you want to call them, there's a lot of these IoT devices they're putting in that just directly go out to the internet, so that's not also a great thing. And some of the benefits of this, why companies are actually doing it, because as cybersecurity students, you probably are thinking, oh, more connectivity means more spaces to get attacked. But the reason why they're actually doing a lot of this stuff is to increase the efficiency so that they can actually monitor and change type of stuff that they're doing inside of their plants. It also gives them a whole lot more visibility. If you have a cyber team for your like enterprise side of the business, you also want them to probably cover your OT side. And so kind of getting those logs in, for example, into your IT, like Splunk or whatever. Additionally, it has a whole lot of integration, so you can quickly pivot what you're doing inside of your factory. But here's a graph here that kind of shows why there's this increase in OT convergence is really just important for security. So only 1% of like actual OT like attacks are only an OT exploit. So like they just like kind of got in and did an exact exploit on an OT device. And 35% of the time, it's an IT and then an OT signatures. So kind of they had to do an IT and then pivot through the IT space into the OT of an organization. And then this graph is kind of confusing because then they said 94 and you're like, that doesn't add up to 100. But basically the total attacks in the OT environment that kind of have the IT involved with it is the 94.4. So essentially, while the OT security is slightly different, it is really important to make sure that you have this convergence kind of secured. But I'm kind of jumping ahead of myself. But
So what even is OT security? Well, it's the practice of these hardware and software systems that control industrial processes, protecting those systems from cyber threats. So like a big difference is like an IT security, if a breach were to happen, it would just be confidential data that would be like the biggest, or like downtime would be the biggest kind of thing that would happen impact-wise to the organization. Whereas in OT security, it's the essential services that we live on, right? So your water, your electricity, all these kinds of things. It can have a actual physical impact and also cause damage to people as well.
I had a question on this slide.
Oh, yeah.
What's the difference between like the 34% number and the 94% number?
No, you're good. Yeah, I kind of skipped over it because this graph was taken from.
Don't think too much on it.
No, it's taken from. God, which survey? It's taken from one of the three.
Palo Alto.
Palo Alto. Okay, so it's taken from the. Oh, it says right there. Yep. Palo Alto Siemens OT report. And so the 94.4% is sort of like the signatures that they looked at in the attack space that actually had an OT exploit in it.
Okay.
Because they were looking at OT environments, but then sometimes, like companies, and then sometimes an attack would only touch the IT. But when a threat actor actually goes after these companies that have the OT space, 94.4% of the time they're actually going after the OT environment. It's sort of what that means, if I explain that better.
Okay, so applying prior knowledge. So why are people who who have knowledge in IT and cybersecurity important for this industry? Well, a lot of the cases you'll run into a lot of people who are in industry on these like industrial control systems and OT environments who their background is in computer engineering or electrical engineering or some sort of engineering discipline. A lot of them know a lot about the actual physical process and like things like circuits and whatnot. They don't really know anything like IT networking, network segmentation, cybersecurity principles. So that's kind of the thing that we bring to the table as cybersecurity majors, because there's people I met in industry who one guy asked, he said about like what was the most important thing to him in OT cybersecurity. It was his engineering degree, because his outlook is different. The kinds of things that we bring to industry are just different.
So yeah, we've kind of been talking about this, like how does OT relate to the IT, but let's just kind of lay it out there. So if we look at the focus, IT's focus is on the CIA triad. Freshmen, if you don't know what that is yet, you'll learn it in 140, but it's confidentiality, integrity, and availability. I always say accessibility. I mean, it's like the same thing, but but in OT, we actually care about the safety and the uptime. And sure, in IT, we also care about the uptime, but in OT, you have that safety aspect. Say you have these industrial control systems controlling like a boiler, controlling the amount of pressure in a boiler, right? And then so that someone gets in and they basically tell it to explode because you put too much pressure in it. Well, that, in the IT space, you're not really going to have a boiler explode. if someone's next to it. So that's one of the main reasons with the focus, but also the impact, right? You got this data loss and downtime in IT, and physical harm and downtime in OT. And downtime in the OT space can sometimes be more impactful because we're not talking about maybe a website. And sure, like if a bank goes down, that's pretty important because then you can't make transactions. But if you don't have power, a lot of our stuff runs on power, obviously. But one of the things that might be not as obvious, in like the vulnerability lifetime in IT is kind of like 3 to 5 years. But if we compare that same data point to OT, it's 15 to 25 plus years. Like there's vulnerabilities like older than me that are still like prevalent, which is kind of crazy. And sort of like pull that out. Wow, that's bright. From the Palo Alto OC Siemens Security Insights 2024 report. This is a distribution of the OT network CVE age. So about 61% of them are from that 6 to 10 year range. But you still have like about 1.4% that are those really, really old that are still actually being like exploited. Now, if we compare that to like IT average vulnerability, you'll notice, average in days. So we're comparing it years to days. So that can kind of be a good look at sort of just like when you're measuring the same statistic, 1 in days and then 1 in years, that you can show the very big disparity between them. Got another graph we got to cover. This is from the Fortinet 2024 State Operation Technology Report. This sort of shows, it says at the bottom, how many intrusions an organization has experienced in the past year. And, you can look at the chart here, the numbers, the colors of the higher means they got like 10 plus or 6 to 9 intrusions. But I kind of calculated the average intrusions they can expect. So in 2022, there was an average of 4.3 attacks per organization, 2023, 2.7, 2024, 3.3. Now, I'd like to point out 2022 was kind of a crazy year for OT because of Ukraine. And so kind of ignoring that. But even looking at 2024 last year, if I was an organization and I saw that like the average OT organization can expect to have about 3.3 attacks per year, I kind of want to hire somebody who can secure my things so I don't get taken down 3 times a year. So that kind of gets into the why you should learn about OT security. OT security skills are in really high demand. There's also that significant impact we've been talking about. And also there's a lot of transferable skills from IT into OT, so you just need to change some of your thought processes, but then also from OT into IT can give you like new perspectives on some of the problems you're facing in the IT realm.
So one of the biggest case studies for a OT cyber attack that caused damage or had the biggest kind of impact on industry was the Florida water plant attack targeting the Oldsmar water treatment facility in Florida, where the adversary was able to gain access to a third-party software package, TeamViewer, which allowed the adversary to remote in and kind of have complete access to the chemicals that they were putting in the water. So in water plants, they put a lot of different chemicals in the water, but they put it at a very small dosage. And the adversary raised the dosage for sodium hydroxide from 100 parts per million to 11,100 parts per million, which is lethal. But the attacker was thwarted. The employee caught in time, so it didn't actually end up killing people. But the fact that it was one of the real things that showed that an OT cyber attack can cause people to die from their own water. And another big thing is all the remote access tools shared the same password, which is not really good. And there was no firewall for the operator's PC, and you could directly connect to it via the internet, which is a big no-no if you have a PC that's connected to these industrial things. So one of the biggest key takeaways is having the most basic cybersecurity principles is often an afterthought in these OT environments. A lot of the times you'll go into these spaces and they just put the password on all their computers, just like in this case. So another big thing is these insecure OT setups can dramatically increase the overall attack surface, because it was so easy for these attackers to just go in and change the chemical dosage for people's water. And so another kind of big OT case study is the 2015 Sandworm campaign on the Ukraine electric power grid. This specific attack was on the Western Ukraine power grid, which includes 3 energy providers, and this also kind of includes areas around Kiev, the capital of Ukraine. And the Sandworm group is an advanced persistent threat group. So how they gain initial access to the internet, the IT networks, and they did this through the Black Energy 3 malware, which is a remote access Trojan. So they had a targeted spear phishing campaign where they went after specific people who in the energy company, and they sent tailored emails that had an email attachment that had was a presentation with macros that allowed them to gain initial foothold into the IT network. And then from there, they were able to pivot through the IT network into the OT network through stealing VPN credentials as well as Active Directory credentials. This allowed them to remote into an HMI, which an HMI is a human-machine interface, which we're going to cover a lot more later on. But an HMI is kind of a dashboard for these operators at these facilities to see everything. And in this case, an electric power grid, it showed all the circuit breakers. So the video we're going to show after the slide is of a phantom mouse. So a mouse going in and clicking on the circuit breakers and turning off everyone in Ukraine's power. And this specific attack caused over 200,000 people to lose power for several hours. And a main reason why it was several hours is because the attackers utilized this kill disk malware as well, which wiped operators' PCs to make it so that they couldn't get their network, the power up right away. And so some key takeaways from this attack is that in OT environments, a lot of the times they don't even monitor or restrict these the access to HMIs, and as well as all these different remote access tools that they utilize. And also, IT breaches can cascade into OT outages. So a phishing email can go from a phishing email all the way to you losing your power, which is kind of a crazy thing to think about. And they didn't do this to just one energy company. They did this to 3 companies. And another big thing is it highlights the need for network segmentation. What I really mean by that is you probably don't want all of your circuit breakers to be accessible for someone to just click on them and turn them all off with one click. So,
All right, here's a video. Hold on, let me just make sure the audio is switched back. It is a video, well, they'll tell you what it is. Wow, that's really stuff.
А що це він зараз робить? Чого ржете?
Це воно секційне щось. Щось
Він
хоче
110
відключити.
хоче.
Що хоче відключити?
А,
Да.
спроба вимкнути секційний 110 кВт. Він у нас не заведений під телемеханіку.
Ні, ми тут не маємо.
Ні, він не заведений взагалі-то під телемеханіку, але спроба це зробити є.
Це от зараз треба винувати. Горочана така є штука, але в них там заведено.
Yeah. Okay, well, so that video is long. You can go, we'll post a link to it if you want to watch the whole thing. But basically, as you saw, it was literally like they're watching their mouse on their computer with a phantom mouse, right? Click all these circuit breakers. Funnily enough, the one they were recording, that computer wasn't actually connected to any of the breakers, but it was happening on multiple machines simultaneously.
yeah. And so probably the biggest OT case study for an OT cyber attack is what a lot of people don't even know is an OT cyber attack, which is Stuxnet. So Stuxnet actually happened before the OT term was coined, because a lot of people didn't even realize in the cybersecurity community that you could take out the physical processes and whatnot. And the target, of course, was the Iranian nuclear program, and more specifically, the Natanz nuclear facility. And the attackers were able to to compromise an air gap network. We're currently in an air gap lab. You can probably notice on the desktop PCs you can't reach out to the internet. So the security architects did do a good job with their initial security. They did kind of know what they were doing, and they were still compromised because they socially engineered. There's a bunch of different ways of how that USB got into the nuclear facility that people debate on, but the point is it got in, and after it got in, it was able to replicate itself multiple times, and then the main target for this malware was to go after and modify PLCs and make it in these PLCs, which is a programmable logic controller. You probably had me either talk to you about what a PLC was or saw it at the RITSEC general meeting. But the PLC is what controls things like your actuator, sensors, whatever you really have in your industrial complex. And in this case, it was gas centrifuges. And so they had their malware go through and change the exports and do some DLL hijacking with the actual PLCs. And they had to know beforehand specifically what kind of vendor the PLC was, because a lot of this industrial equipment is completely different depending on the vendor. A lot of the protocols are different, a lot of the ways you communicate with are different. There's a lot of differences between these different PLCs. And of course, the real target was wasting uranium. So the way Stuxnet worked was every 27 days, it would speed up the gas centrifuges, waste a bunch of uranium, and then go dormant for 27 days, and then do the same process over and over again. And so one of the biggest key takeaways is that even in the most secure OT environments, there will still be gaps in your security, whether it be a 0-day vulnerability or whatever it may be. If you have a bunch of countries working together to go after your complex and spending millions of dollars, the chances of you getting hacked are pretty high, I would say. So a lot of it is that you have to think about how can I have the most visibility of these nation states coming in.
Yeah, so some of the OT security challenges that you might not experience in the IT space. So first off, you got a lot of legacy systems, and while that is also sort of true in the IT space, these legacy systems are a little bit different because a lot of them have like zero built-in security. So like you can't give them a password. There's no like authentication to make sure it's like the right thing sending it information. So like literally, if you got into one of these networks with some of the legacy systems, you can literally just like send it some code, and it'll be like, great, I'm going to do that now. And so that's one of the major differences in the OT space.
As well as you can't turn off for updates, because if you turn off one device that's connected to the entire industrial process, that entire industrial process will go belly up, because then everything that's connected to that will then be like, oh, well, I don't got my component anymore because it's taking some downtime to update it.
In addition to this, sometimes you're like not allowed to update. What I mean by that is like not like you're physically not allowed to update it, but say I'm an organization, I get this really expensive, fancy piece of like hardware with some software on it, and well, it's really expensive. So the vendor I'm buying it from, I want a warranty to make sure if they install it wrong, I'm not getting a penalty. I don't have to pay for another one. And then the vendor also wants to make sure that if they installed it correctly, I'm not touching it and like breaking it, so that they don't have to pay for another one. So basically, they kind of say, hey, if you touch it, it's on you. And so a lot of companies will kind of choose not to do these updates because, well, if it breaks or if it gets attacked, that might be actually better for their bottom line in the long run.
Another thing which I probably already mentioned quite a bit is the weak network segmentation. So sometimes you'll have industrial complexes, if they had no dedicated OT or any security person, they might often run on a flat network, which means that everything can talk to everything, which in the mind of attacker, if you get into an industrial complex that has just everything can talk to everything, well, it's a playground.
Yeah, there's also a lack of monitoring and like monitoring tools for just everything in OT. So we have this graph up here, and so we see like Trojan, malware is Trojan is like 9%, ransomware 9%, adware 2.5%. But then you see this massive 78.4% is just like unknown. And you might ask, well, okay, how is that unknown? And well, the answer to that question is because there's like no monitoring. So they might see that something's going wrong in their industrial process, and then like stop it, and then like through reverse engineering sort of, but figure out, oh, we actually got hacked or something like that. So like there's literally so little monitoring.
Another thing is you oftentimes can't use Nmap or like any other kind of port scanning tool in some of these OT environments, because if you scan all the ports, you might take down one of these like $100,000 pieces of equipment they have sitting around in their industrial complex. So what I really mean by that is you can't, a lot of things you can do in IT security and pen testing, you can't do in these OT environments because you have to think about that industrial process. And if you take down one of those things, it's just, it's gone. So.
Yeah, so some of the challenges, just to kind of recap and sort of how they impact on each other. You got legacy systems with no built-in security. Then you can combine that with the fact that you got a weak network segmentation. So if they get in, they can kind of access everything, and there's no like authentication stuff on some of these systems. And obviously updates, so that's kind of why they're legacy. And then you got the lack of monitoring, so you don't really know what's going on in your industrial processes sometimes. But someone who doesn't know one of these challenges, who might just like hop in to a system coming from cybersecurity, might say, just updated and rebooted all the PLCs. Who said OT cybersecurity is hard? Well, that person with all the downtime they just created might have cost the company, I don't know, depending on the scale, about $10 million. So
Probably more.
right, so they're not the best choice there. But going back to like visibility, this is another graph from the Fortinet 2024 State Operation Technology report. And so we're going up in our average visibility into these networks, but we're at 64% are visible to like organization central like cybersecurity operations. So like basically half of the stuff in these OT networks, the cybersecurity operations have zero visibility on, which is kind of wild. It's like imagine trying to run your network and like literally you only know about like half the stuff in it. It's like not very good for security.
So why engage in this interest group? Well, we plan on doing a lot of hands-on learning. So this is the first meeting, so we wanted to keep it just kind of more high level and intro. But for future meetings, we hope to have like a lecture for the first kind of part, whether it be like a meeting where we go into like the basics of like OT, or we talk about a specific malware campaign or malware sample. But we also plan on demoing different things like a simulated OT environment, doing small group projects where that'd be like activities where you guys actually get to like hack a simulated piece of software, because at the end of the day, we can't just buy a lot of physical hardware, because my micro PLC costed $250, and that's a micro PLC. The real PLCs are like 1,000 plus. As well as tool demonstrations. There's not too many tools out there, but there is a fair amount, which includes things like fuzzing a PLC or what have you. Another thing is project support. Since a lot of our learning has been project-based, we want to be kind of a resource for you guys if you guys ever want to start an OT security kind of based project or something involved around it. We hope to really be a good source for you guys to, get you in contact with other people as well if you want to start a project. As well as we have a lot of projects that we are currently in progress, idle, or we just thought of it and we just don't have the time to really spend on it. As well as some of the projects we've already done. This was our kind of first dabble in OT security, and this was a simulation of a kind of a part of an industrial, like a water plant, where we simulated like the basics of just having some components live in Docker and whatnot. But the other big thing the big thing we've kind of done is this industrial network template, which is live on GitHub. We have links on our LinkedIn's as well as in the slides probably of this repo. But basically, this is a repo where the plan is that people would clone the repo, and then they have a good starting point for starting out like a project. So it already has like a bunch of scripts that are kind of dynamic, so that like, let's say you wanted to add or delete some containers in your project, you can easily do that and run the scripts, and it will run fine. So
And we tried to add documentation, but if you ever have any questions about anything in all of these, please message us because, you know, you work in something super long and then you're like, we got to give this to other people. We should do some documentation. You might forget some simple things. So,
yeah, so
yeah, so kind of continued on why to engage in the interest group is we kind of ever covered this a little bit, but sort of like the topics that we kind of want to cover inside of the meeting. So like this one, we kind of did like the high level OT, sort of like what is OT, intro to stuff, what we kind of plan on doing this semester, right? But then we also kind of want to go into some like, you know, the attack defense strategies and also like malware deep dives because those are always really interesting. And then, of course, if any like OT events just kind of like pop up during the semester, we plan on talking about those because crazy stuff is happening.
as well as possibly a competition in the future.
Far future.
Far future, probably in like a year or what have you. I don't know. But the thought behind it is we would create a bunch of simulations, and then after a while of having a bunch of these simulations, turn into an actual competition where people would red team in and hack actual OT like simulated environments we create. So that's kind of the scale of where we see this interest group going, as well as industry panels. So we're currently planning an industry panel for sometime near the end of September or beginning of October, where we'll have people who are RET alumni working in industry come and talk about their experiences in industry and whatnot. And we also plan on having that as kind of like a core thing that we do throughout the coming semesters and whatnot, as well as meet people in industry. So also back to the project thing, if you have a project and we don't really know anything and there's not really good documentation out there, we can always try to put you in contact with someone who's in industry.
Yeah, just a quick overview recap. No, you don't need any prior knowledge in OT or really security, although, some topics we'll be moving quicker to not like bore everyone to death. But so if you ever have any questions, just please contact us. Also, we went over, what OT is, how critical it is, also kind of like how vulnerable it is, like surprisingly so. And then also how it's being increasingly connected to the IT space and how the IT security can kind of, you need that plus the OT in order to secure these OT environments. Additionally, we kind of discussed our group is planning on offering like this hands-on learning and like project opportunities. We as he said before, we kind of learned through just doing projects and being like, all right, we want to do this thing, and then how do we do that? And then just doing a bunch of research and trying it out. Additionally, everyone's welcome if you actually like want to study OT more in depth, or if you just kind of want to come here and hear about any like the random malware attacks that happen or campaigns.
Yeah, and another thing to add is our next meeting will be on the core OT components. So we'll have demonstrations of the different components that are in industrial complexes.
Yeah, but then we'll cover all the stuff that you might have heard of, like PLCs, HMIs, SCADA, just a whole bunch of that stuff. Trying to get you. This is the intro. That'll be like here's all the components, and now we can kind of go run.
Yeah.
Yeah, that's all we had. If you have any questions, feel free to come up. But yeah, thank you.